Yeah, let's rock. Today, guys, we're going to go through Newton's first law of motion. And in this whole unit, we're going to look at all of Newton's laws, which are going to focus on the state of motion and what are the causes to how things move and do what they do. So first of all, we're going to focus on the different states of motion. So understand that when an object is moving, we can see an object's velocity as being constant or changing. So this is stuff that we focused on in our first unit. Things being constant means they're moving at a steady pace, as shown maybe in this first picture. Or when things are changing, we can look at things either speeding up, as we see here, slowing down possibly, speeding up as we see here, slowing down, and then possibly changing direction. But what Isaac Newton did is he realized that depending on your state of motion, whether it's constant or changing, there's a reason behind why that is occurring. And what we're going to do in this unit is we're going to focus in on the reasons to why things do the way they do in terms of their motion. So first of all, when it comes to the states of motion and why things are either moving at a constant speed up or slow down, but the state of motion is all due to the forces acting on an object. So this entire unit, we are going to focus on this idea and this concept of a force. So force is going to be a push or a pull that's acting on an object. Meaning I can take, for example, a ball as shown here, and I can take this ball and throw it up in the air. But in order for that ball to do or actually go up in the air and fall back down, first of all is I need to push it into the air. Then as it goes up in the air, it's going to go up and down, and the reason why is because it's being pulled down by gravity. Okay, so there's a push and a pull that's acting on this object to make it do what it does. Same thing here with this soccer ball. Is this soccer ball would just sit here unless kicked by this object or this person. So when it's being kicked, we call that a force. Okay. So our force we're going to symbolize with a capital F. In units, we're going to look at either pounds or newtons, and what we're going to focus on in this unit for our units of force are going to be newtons. And just understanding then the world we live in, we use pounds more so than newtons. But just know that pounds and newtons are representing the same thing. They're describing a force acting on an object. So within this unit, we're going to focus on how forces cause an object's state of motion. What Newton realized is that when forces act on an object, those pushes or pulls, that there's not just a single isolated force acting on an object making it do what it does. So for example, if I have, let's say, a ball resting on the ground, we see that ball as being at rest and not moving. So when we see a ball being at rest, we see that nothing is acting on that ball, that there are no forces. But what Isaac Newton realized is that even though this object is sitting at rest, does not mean there's no pushes or pulls acting on the object. What he realized is that there are actually objects or things pushing and pulling on this. For example, as we can see by the person and the book sitting here, that while this person or the book are sitting there, there's actually gravity pulling down on them. Gravity is making the things come towards the surface of the earth. If there was no gravity, those objects would just float. But at the same time, if gravity is pulling down, we would expect things to be in free fall. But an object standing there, a book resting on a table, is not in free fall, which means that there must be something opposing gravity. In this case, it's the floor or whatever supporting the object or pushing back upward on that object. So what he realizes is that certain types of motions are caused by what are called balanced forces. Balanced forces, as you might think, are anything that cancel each other out. So the forces that are acting on the object simply add up to equal zero. This is very similar to when we did like distance and displacement. If I have, let's say, an upward arrow here and a downward arrow here, if I were to fit numbers and say, this is 10 newtons, then this one would also have to be 10 newtons. But what happens is that they're opposing each other. So one up and one down, if I label one as negative for going downward, the total sum of the forces here would be 0 newtons. And he recognized that if the net force or the sum of all the forces equals 0, then that means the object is going to have a certain state of motion. Versus if forces are unbalanced. So unbalanced would be, again, if you add up all the forces and they're not equal to 0. So you'll see in this diagram I have an upward force and a downward force. And by those arrows shown, we can see again, maybe both these forces are 10 newtons and negative 10 newtons. So in that direction, it may be balanced. But But notice here that I have a force going against the book. So if it's sliding to the right, this is friction acting against its motion. Now, friction, as we know, would cause the object to slow down. So we recognize then that if the object has unbalanced forces, it's going to cause a certain type of motion. But unbalanced means that there's going to be a certain part or portion of the force that is not canceled out. And this brings us then to what Newton realized, that it's not about individual forces, but instead it's about what's called the net force. So the net force is a fancy way. Net is the fancy way of saying sum. A net force is not an individual force, but instead we view it as the sum of all the forces acting on the object. And that the sum of all the forces indicate what's going to happen to an object. So here if I have 1,200 newtons upward and 800 newtons downward, notice that they're not balanced out. I have up and down, but in numbers wise, there's more up than there is down. So that means it's going to create a net force of 400 newtons upward. Same thing here. I could have kind of like an object falling, experiencing gravity and air resistance, that if there's 800 newtons downward and 600 newtons upward, those forces are not balanced, creating a net force of 200 newtons downward. And then here, I could have a balance of forces up and down, but then I have this leftward force of friction. So say this is an object moving on a surface, but there's nothing to balance out this 20 newtons. That means there would be a net force of 20 newtons pointing to the left. So the first thing we're going to understand is whether forces are balanced or unbalanced. So our first example, just going to go through this real quick. Notice the first here, I have an upward arrow, downward arrow, one to the left. So balanced or unbalanced, in this case the object would be unbalanced due to the force of the left that is not balanced out. Same thing here, if I look at balanced versus unbalanced in my second diagram, I have an up and a down, and now I have a right and a left. But notice how the right and the left, how there's more right than there is left, so that means this is going to be unbalanced. Versus here, I have an up, a down, a right, and a left, so I have 4 forces acting on the object, but notice all those forces are equal and opposite. They're same length of arrow pointing in the opposite direction, so this would be balanced. Now, what we're going to get into then is by recognizing whether forces are balanced or unbalanced, that's going to tell us then about the motion of the object. Okay, but before we get into the motion, what we're going to do is now fit numbers to it. Okay, now let's fit in this idea of a net force. So let's say that I have unbalanced forces like I see here, 40 up, 40 down, 10 to the left. We know that this is going to be unbalanced forces because there's 10 newtons to the left that are not balanced out. So when I look at the net force is going to be the sum of those. So in this example, since I look at up and down, even though it's not labeled, this would be a positive 40 upward, negative 40 downward. So those two would result in 0 newtons. But notice here how there's nothing to balance out the 10 newtons to the left. So I know in this case that the net force is going to be 10 newtons, and I can indicate the direction to the left. I could also label this, if I wanted to, negative 10 newtons, using negative as using negative to represent that leftward direction. Next example, if I see something that is balanced. So here I have gravity and the normal force both equal and opposite, so I know the forces are balanced. If I have a balanced force, I'm going to add these like positive 20 and negative 20. What those are going to add to is 0 newtons. So when forces are balanced, the net force is going to equal 0 newtons. Same situation here. If I have up and down, I know here this is going to be unbalanced and that there's going to be 15 newtons left over, and that is going to be directed upward. So now we recognize whether forces are balanced or unbalanced, which creates a net force, and then we're going to indicate then next what that net force is going to do to an object. So what Newton then realized is that first, everything is about this net force. It's all about whether forces are balanced or unbalanced. So what we're going to focus on today is what's called Newton's first law of motion, which has to deal with balanced forces. So what you want to do is by recognizing that there are more than just one or no force acting on an object, that we can have multiple forces, that the first state of motion that an object can be at is all dependent on whether forces are balanced or unbalanced. And this is how he came up with his first law. He states that an object that at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an unbalanced force. So the key part of this is the whole last part of unbalanced forces. All right, so the unless part means that if forces are balanced, the object is going to remain at rest. So for example, I could have gravity pulling downward and a support force of the surface upward. If those forces are balanced, the object could be at rest. Similarly, if an object is in motion here, it's going to tend to stay in motion. So here, I know this is kind of an interesting one to look at, but if a ball is moving, it's going to tend to stay in motion. And let's say this ball is at rest. The only way to put this ball in motion is if I were to apply some sort of unbalanced force, like let's say kicking the ball. That if I apply an unbalanced force to that object, then it's going to start to change its motion. So if it's at rest, it'll start to move. And if it's already in motion, then it's going to start to speed up or slow down. But Newton's first law talks about when things are balanced, they're either going to be at rest or they're going to be moving in a constant speed, meaning it'll stay in its motion. So understanding how does this relate then to Newton's first law and the idea of balanced and unbalanced forces. So if forces are balanced, according to Newton's first law, we will see an object will stay at rest or will be moving at a constant speed. So when it says an object at rest will stay at rest versus an object in motion will stay in motion, that's referring to these two things, and that's assuming we have balanced forces. Versus unbalanced forces will cause a change in speed. So understand a change in speed, like we talked about last unit, could mean that the object is speeding up or it could be slowing down. So one of those two options, but we're also going to start focusing on possible change in direction. So any part of the motion that ever changes is going to be due to some sort of unbalanced force, which means that the forces in either direction are not going to cancel each other out, not going to add up to zero. Okay, so let's kind of put this together. So now let's see if we can understand the idea of whether forces are unbalanced or balanced and how that relates to the motion. So in this first diagram, I have a car, and we recognize in the dot diagram that I know that this car here is speeding up. So if it speeds up, what does that tell me? Is the forces balanced or unbalanced? Well, that tells me that the forces are going to be unbalanced, okay? Second picture, if I see that the dots are equal distant, then I know that this object is moving at a constant speed, which then tells me if it's moving at a constant speed that the forces are balanced. And lastly, if I see that the object is slowing down, then I also know here that it would be unbalanced. So again, the type of motion is going to be dependent upon whether our forces are balanced or unbalanced. So being able to recognize that is essential. Okay, so what we're going to do here is we're going to match those dot diagrams from the previous example to now a force diagram. So force diagram is just indicating the forces acting on it. In all the three examples before, what we had was we had a little car that was moving to the right. And in example one, or the first part of it, we saw that it was speeding up. The second one was constant speed, and the third one was slowing down. So I'll just label those as A, B, and C, okay? So which of these diagrams is going to represent an object moving to the right that's going to be either speeding up, moving at a constant speed, or slowing down? So what we talked about last unit is that when an object speeds up or slows down, that's called an acceleration. And those accelerations were caused by something. So now we're going to look at the cause. And what we talked about last time is that if something is speeding up, we always talked about how the acceleration it experiences and the velocity would be in the same direction. So if this object, let's say, for example, is moving to the right and it's speeding up, that means there must be a net force acting to the right. So diagram A from example 3 would go with this force diagram here in the middle. Because here I see that there's an unbalanced or net force that would be acting in the right, which would mean that the object would speed up. Okay? Opposite to that is that if I had an object moving to the right and it was slowing down, that means it would experience a leftward acceleration, which would be caused by an unbalanced force to the left. So that diagram C, where we saw it was slowing down, would relate to this force diagram where I have an unbalanced force to the left. And here where I have balanced forces, as Newton's first law states, this is going to result in a constant speed, which would match up with B. So understand now that the forces acting on the object are going to indicate what the object does. So Newton's laws in general are going to explain how forces being balanced or unbalanced are going to make an object either move at constant speed or be at rest or speed up or slow down or possibly change direction. So understanding that there is a cause to how objects move. And this is what Newton realized, and he developed 3 simple laws that indicate how forces affect the motion of objects.